So we just learned about the general term. And what we're going to learn about here is how we use the general term with sigma notation. So how this comes into play is the general term was really just about terms. So the first term, second term, third term. Well, what about when a question asks you to express the sum of those terms? So the actual expansion itself. You can see it's going to be way too much effort if we're going to have to write out each of these terms. So this is where the sigma notation comes into play. So do you guys remember the sigma notation? So the sigma notation is this notation here. So it just looks like a funny looking E. Now what you need to know about the sigma notation is that k equals to 0 here tells us that the first term we want to be starting to sub in with 0. Whereas n up here is the same as the index of the expansion, as well as it tells you the last number you're going to be subbing in. So if it's 0 to 10, for example, it means you want to sub in k equals to 0 to 1 to 2, etc. until it equals to 10. All right? So that's how we use the sigma notation. So that essentially represents all of this. So this is telling us that it's the addition of from when k equals to 0 until k equals to n essentially for the expression of the general term. So this is how the general term fits into there. That means we actually want to write the general term as an equation, an expression, rather than as just that term there. So remember, the general term was given to us as tk plus 1 equal to nck, a to the power of n minus k, and b to the power of k. So this here tells us about the actual expansion for that a plus b to the power of n, when you do expand it all out, equals to exactly the same as what this is telling us. So remember, this is telling me that I'm going to be subbing in starting from k equals to 0 until that number there, which is the same as the index, for this general term here. Another thing to note is that n, which is the same as that index, with n plus 1 is a number of terms. So if you have 10 there, you know the number of terms should be 11. So now we know the sigma notation, which is to using the general term, but when we want to work out the actual expansion, so adding all the terms together. That's how I want you to think about the sigma notation. So let's practice writing things in sigma notation now with some examples. We want to write down x plus 2y to the power of 20 in sigma notation. Now remember the sigma notation, since it uses a general term, to write anything in sigma notation, the first thing we need to do is work out the general term of this. So tk plus 1 in this instance will just be 20, because that's 20 ck, x to the power of 20 minus k, and then 2y power of k. Super simple there. And now we just put it into the sigma notation. The expansion of all of that equals to the sum of this general term here, starting from subbing in k equals to 0 until we sub in k equals to 20. That's saying to me there. So how I know what to write is just write the term, your sigma notation there. This is always k equals to 0, okay? Remember that. Whereas this is the same as that index. And that's all you need to know for writing that sigma notation. So here we want to write down x plus 2 on x to the power of 32 in sigma notation. So first thing is a general term. So general term here, tk plus 1, is just going to be 32 ck, x to the power of 32 minus k, and then 2 on x to the power of k. Now, as you can see, because these are both x and x, we know we can simplify that somehow. So we're just going to make this into 2 to the power of k, and then x to the power of negative k. These are both x's, which means we can add the indices together. So we have 32 minus k minus another k. So that's 32 minus 2k to the power of k, and that's 32 ck, exactly the same as that. Finally, let's put it into the sigma notation. So remember, with the sigma notation, I want you to write it as that, firstly, equals to So sigma notation, always k equals 0 first until 32, which is your index, and you just need to write your simplified general term over here, and that's it. So it's really simple. All you need to remember for sigma notation is you always start off with k equals 0 here, and this is the same as our index, and you need to find the general term first to write here. Yeah, the other little note is if you do see x and x or a and a, just remember to simplify first.